Good morning, students. Dear students, today, in continuation with video lectures on laws of motion, that is chapter 5, we are proceeding towards part 3 of the video lecture. And in the previous video, we had studied about laws of motion. We had studied about laws of motion, what is meaning of laws of motion. After that, Newton's laws of motion. Newton's laws of motion we had discussed. Then we had discussed about Newton's first law of motion. Newton's first law of motion. After that we had discussed Newton's first law defines inertia. Newton's first law defines inertia, and then we had discussed about inertia. All things we had discussed in the previous video. Now in today's video we will discuss the most important part of the chapter, that is Newton's second law of motion. We will discuss about Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. What is Newton's second law of motion? The Newton's second law of motion, as you had studied in previous classes also, Newton's second law of motion states that the rate of change of momentum, the rate of change of momentum of a body is directly proportional to the external force directly proportional to the external force applied on the body. External force applied on the body, and due to this application of external force, since external force is applied on the body, due to this application of external force, there is the change takes place in the body. So the changes are in the direction of applied force. The changes are in the direction of applied force. So dear students, the rate of change of momentum. Whenever we talk about the rate of change of momentum, then we will discuss about del P upon del T, that is rate with respect to time. And this rate of change of momentum is directly proportional to the applied force. Rate of change of momentum is directly proportional to the applied force. So look at here. Look at here. If there is a body, certain body, and force is applied on it, then its momentum mass is constant, mass is fixed, mass is uniform, there is no any meaning of change of mass. Velocity changes, so momentum also changes. So when a force is applied on a body, then its momentum changes. Look for the derivation of it. We will discuss about the derivation related to it. F is the external force. So dear students, we are talking about the rate of change of momentum. So if F is the external force on the body in the direction of motion of the body, in the direction of motion of the body in time interval delta t. Velocity changes from due to the application of force. As I had told, velocity changes from v to v plus delta v, means the change in velocity is v plus delta v. So change in momentum that is del p. Change in momentum is del p is equal to m into delta v. Change in momentum is m into delta v. Now according to Newton's second law, Newton's second law, F is directly proportional to delta P upon delta T, or you can say that F is equal to K del P upon del T. Proportionality constant, where K is what? K is equal to proportionality. K is nothing, so K is proportionality. K is called as proportionality constant. So if we consider, if delta t tends to 0, if it happens that delta t tends to 0, then limit delta t tends to 0 del p upon del t, it can be written as dp upon dt. So we can write it as force is equal to K dp upon dt, and if K is considered as 1, then F is equal to dp, then F is what? F is equal to dp upon dt. F is equal to dp upon dt. Now as you know that the momentum P is what? Momentum P is equal to m into v. As you know that P is equal to m into v. As P is equal to m into v, so F can be written as dp upon dt equal to d upon dt m into v, and it can be written mass, since mass is constant, so constant is taken out of the derivative sign, and it will be dp upon dv, and from here F is equal to, since you know that dv upon dt is what? dv upon dt is equal to acceleration. So from Newton's second law we had got force is equal to mass into acceleration. Force is equal to mass into acceleration is the result of Newton's second law of motion, that is rate of change of momentum is directly proportional to the applied force, and it is in the direction of the applied force. Now 1 unit force is equal to 1 unit mass into 1 unit acceleration. 1 unit force is equal to 1 unit mass into 1 unit acceleration. So 1 unit of force is defined as, how 1 unit of force you can define? One unit of force is defined as the force which produces unit acceleration, the force which produces unit acceleration in a body of unit mass, in a body of unit, in a body when a body of unit mass produces an acceleration, then that force is called as 1 unit force. So it can be written as what? In SI it is written as 1 Newton is equal to 1 kg into 1 meter per second square, or it is equal to 1 kg meter per second square. So 1 Newton is equal to 1 kg meter per second square. So dear students, we have discussed about the SI unit of force. Now in Cgs unit, all things you are knowing, students, I am just revising it. Absolute unit of force is dyne. Absolute unit of force is dyne. So 1 dyne is what? 1 dyne, since this is Cgs unit, so 1 dyne is equal to 1 gram into 1 centimeter per second square, and it can be written as 1 gram centimeter per second square. Now gravitational unit of force. Gravitational unit. Gravitational unit of force. Gravitational unit of force is kilogram weight. Kilogram weight, or you can say that kg weight, and it can be defined as that much force, which produces an acceleration of which produces an acceleration of 9.8 meter, that is the value of g, 9.8 meter per second square, in a body of mass 1 kg. If a body of mass 1 kg and it produces an acceleration of 9.8 meter per second square, then it is called as gravitational unit of force. Then how can we describe the gravitational unit of force? Gravitational unit of force, 1 kg weight, which is equal to 1 kilogram force, and it is equal to 9.8 Newton. Various times you had seen that the force is kg weight or kgf. It is written in numerical. It means that 49 into 9.8 Newton. In this way you can express it. Now this is SI unit of gravitational, this is SI unit of gravitational unit of force, that is kg weight. Now in Cgs system, what is the gravitational unit of force? Gravitational unit of force in Cgs system. Gravitational unit of force in Cgs system. In Cgs system, gravitational unit of force in Cgs system, gravitational unit of force is written as gram weight or gram force, and it is defined as that force which produces an acceleration of 980. Since it is Cgs system of units, so we take 980 centimeter per second square in a body of mass 1 gram. In a body of mass 1 gram. So 1 gram weight equal to 1 gram force, and it is equal to 980 gram centimeter per second square. Gram centimeter per second square. Now this is all about the unit of force, and we have defined the forces by Newton's second law. Now we will discuss about a relation between Newton and dyne. Relation between Newton and dyne. So 1 Newton can be written as 1 kg meter per second square, and it can be written as 1000 gram into 100 centimeter per second square, and it can be written as 10 to the power 5 gram centimeter per second square. And as you know that 1 gram centimeter square is equal to 1 dyne, so it is equal to 10 to the power 5 dyne. So 1 Newton can be written as 10 to the power 5 dyne. So dear students, this is all about for today, and tomorrow we will discuss about impulses, because in your syllabus these things are only for recapitulation, so we are not going to discuss about the numericals. So in the next video lecture we will discuss about the impulse, what is impulse and its derivation, and after that Newton's third law and its applications, and after that we will proceed further. So thank you students, have a nice day, take care.